Hi Ma, how are you?
Hi, sir. Good evening. I'm good, sir. How are you?
I'm good Ma. Thanks for asking. And finally, we are here to take you mock interview. And I've
Yes.
seen so many people and so many, not everyone showing this much of passion. And you're one of the person who are showing too much passion in networking. I really appreciate you. And yeah, so are you ready for mock interview?
Yes.
Okay, Ma. Fine. So yeah, please introduce yourself and yeah, I will start technical part. Okay. Yeah.
Y- Yes. Good evening. My name is Rashmi KH. I have graduated from VT University in the stream of Electronics and Communication. So I have an experience of 5+ years in the networking field. Being a networking engineer, my roles and responsibilities are like troubleshooting networking issues such as circuit down hard issues, circuit flapping, bouncing, circuit latency, circuit packet loss issues. I worked for Verizon project. We used to get tickets from the ticketing tool. I used to handle priority one, highly escalated tickets, which are escalated to director level or executive level. So, I worked, as I informed, I worked for Verizon project. So, I have hands on experience on Verizon owned devices such as Overture 1400, Overture 45 plus, 5100, and Sienna devices, ANDA device, and FlashWave 9960, Telabs 8860. And I also have an experience on Cisco devices such as Cisco ASR 1K, 9K, and Juniper switches as well, like MX240, MX480, MX960, and EX4300 switch. I worked on both the protocol level issues and the hardware level issues. More, I worked on hardware level issues. So whenever we used to get the hardware level issues such as device failure or SFP issues, fiber cut issue, fan tray issue, power related issues, we internally used to dispatch one of our field technician to the customer site. He used to provide us a remote loop, and using that, we used to troubleshoot the issues. And I worked with many internal teams, such as the higher level outage team and also with the local carriers. We used to have local carriers between Verizon and the end customer. I worked with different local carriers such as AT&T, Comcast, Frontier, and I also worked with my senior engineers and gained good knowledge. I also worked on a switching part, that is VLANs,
Mm,
and I used to document
mm,
the RCAs, that is root cause analysis, with the timestamps and whichever internal teams were involved, and what are the pros, cons, and how can we avoid this same issue in the future, and what are the RFOs, that is reason for outage, and is that the permanent reason for outage, so that we can avoid the chronic reoccurrence of the same
mm,
issue. These were my roles and responsibilities in my previous organization. And currently I'm looking for a better opportunities in the product based companies, sir. And I recently cleared the Junos JNCIA exam and got certified from Juniper or HPE currently.
yeah,
That's it about me, sir.
yeah,
Thank you
that's a
for providing me
fantastic. Yeah,
opportunity.
that's a fantastic experience you have in networking domain. You covered everything like hardware level and protocol level and critical issues. Very good.
Yes.
And so worked for 5 years for same company. Client is a Verizon itself, or
Yes, I worked for same client.
okay, fantastic. Okay, let's start with basics. Okay, so I would like to share my screen and will ask you. Okay, so
Sure.
yeah, so let me share my screen quickly. Uh, so are you able to see ma?
Yes.
Yeah. Okay. Now, are you able to see my screen, right? Yeah.
Yes, I'm able to see.
Yeah. So consider there is a switch. Okay,
Okay.
and this is a computer. Just understand it's a computer and it's a computer too. I'm connecting, to this switch. Okay. Yeah. Now this is a, and you also have a router here. Okay. Let's minimize little. Yeah. Let's connect like this. Okay. Okay. Now, and this router have internet connection like cloud. Just consider it has an internet connection. It is a Google Cloud. You can say like Google Cloud, whatever it is. Okay. Yeah, it has a connection with internet. I hope you understand the topology. Okay.
Yes.
Yeah, fair enough. So now, okay. So from this topology, I would like to ask all the questions. Okay. Uh, okay. Now, the PC1 IP address you can consider 192.168.1.1/24, and the PC2 IP address is 192.168.2.2/24. Now, my first question is, if I initiate a ping from PC1 to PC2, will it ping or not?
Yes. Yes, it will ping.
So see my configuration clearly, and yeah, tell me, ma. So if I initiate a ping from PC1 to PC2, will it ping or not?
Okay, I see the PC1. It is the network for the PC1 is 192.168.1.0,
Okay,
and the PC2 network is 192.168.2.0. So
okay,
they both are in different networks. It won't ping.
okay. So how you come to know this network ID? How you calculated it?
So the network ID is calculated based on doing the AND operation between the subnet mask and the IP address.
Very good, fair enough. So now it is not ping. Okay. Now if I give it, 1.12, will it ping?
Yes, sir. Both belongs to the same network 1.0. So both
Hmm.
the PC will ping.
Very nice, ma. Fantastic. Okay. Yeah. So now, uh, let me one thing. Hmm, Yeah. Okay. So this is a topology, right? Now the next question is, uh, I don't have any IP addresses to my computer. Okay. I just purchase a PC. Just imagine this topology. Okay. I just purchase a PC. Okay. And this is a setup. Okay. I want to access the internet. What are the things I need to assign to a computer? And in this topology, what are the protocols you will configure? How I can access internet? Whatever you know the steps, you can tell me now.
Okay, when we take a fresh PC, a new PC, there won't be an IP address. So, in order to assign an IP address and all the other internet configurations like IP address, subnet mask, DNS server, and all, we need
Mhm,
to assign we need to configure the DHCP protocol. So, DHCP protocol, it is the dynamic host configuration protocol. It is one of the network configuration protocol which automatically assigns the
mhm.
IP address, subnet mask, gateway, and the DNS servers. So
Okay,
how it uses the DORA process, that is
okay,
discover, offer, request, and acknowledge, and it
okay,
uses the UDP protocol with the
okay,
port number 67 and 68.
okay,
So let
okay. Let me stop here. So you will configure a DHCP, right?
yes,
Sorry, let me close all these tabs. Okay, it means you will configure a DHCP. Yeah.
yeah.
So where you will configure a DHCP, ma?
I will configure on the switch, sir.
This switch, this switch
No, I will configure on router.
router. Okay, you will configure a DHCP on router. The DHCP pool
Mm,
you will define. Okay.
mm.
So now how DHCP works, you explain with the DORA process. With the packet level you are trying to explain. Yeah, now you can go ahead. So you will configure a DHCP on R1 router.
Yes.
Okay. So now you explain the process. Yeah, please go
Yes, the ones the DHCP. We have one
ahead.
client and the one the DHCP server.
Mm-hmm.
So client will be having the MAC address M1, and the DHCP server will be having the MAC address that is M2, and let's say it has an IP address 1.1.1.254.
Mm-hmm.
So now the client uses it will request the DHCP server to assign a IP address. So what and all fields it will send is the client will send is one is the source IP. Source IP we don't know. That is why it will be 0.0.0.0, and
Okay.
the destination IP is also unknown for us. So it will broadcast, that is
Mm-hmm.
255.255.255.255,
Mm-hmm.
and the source MAC we have is M1, and the
Mm-hmm.
destination MAC is M2, and along with this
So which
it
packet
uses
is it? Which packet is it?
It uses the UDP protocol.
Yeah, protocol. Okay. What is the packet? Is it client is sending
It is the request packet, discover packet.
Discover packet. So in Discover
Yes.
packet, do you know the destination IP also? Oh, you said it's broadcast, right? Yeah.
Yeah, it will
Okay.
broadcast, and it will also contain the UDP protocol, and it uses the source port is 68 and the destination port is 67, and it
Mm,
also contains the DHCP payload. In
okay.
the DHCP payload, we will have the client MAC address, that is
Mm,
M1,
mm,
and we will also have the DHCP packet. The option
mm,
is 53, and
mm.
the type of the DHCP packet first we will send is the discover one.
Yeah.
So all this information reaches the DHCP server.
Mm,
In the once it reaches the DHCP server, it will check for the destination port, that is 68, 67. It will recognize as its own port, and it will see what we are requesting. We are requesting for the IP address, so it will provide the IP address. Now it becomes, the source becomes 1.1.1.254, and the destination IP is still the broadcast
mm.
255.255.255.255, and the source MAC is now M2 and the destination MAC is M1. And
Are you
in
sure it will learn the MAC address without having IP address? What is the all DHCP packets or broadcast or
Yes,
ucast?
it will be broadcast.
So it means the destination MAC address is
Yeah, destination MAC address still will be broadcast. That
yeah,
is FFFFF.
yeah.
And now in the DHCP payload, we will have the client MAC
Mm,
M1, and
mm,
the DHCP options. From the pool, it will offer few things,
yeah.
like DHCP option number one, it is used for subnet mask.
Mm,
DHCP option number three, it is used for gateway router.
mm,
DHCP option number 6 is used for DNS server.
mm,
Option number 50 is used for requested IP address.
mm.
Option number 51 is used for lease time.
Very
Option
good.
number 54 is used for type of DHCP packet. Option number 54 is used for server identifier.
Yeah.
All this it will provide, all this will be reaching the client, and
Mm,
from the offer it will accept the offer, and it will request it to please allocate me the IP address. Now the DHCP server will acknowledge this request, and it will allocate one of the IP address
mm.
to the client.
Okay. So now your PC got a IP address, subnet mask, gateway, DNS information. Now
Yes.
what next? Now I want to ping google.com. What is the process?
Yes. Now we got all the details, like IP
Where are
address.
you looking? Where are you looking? Is it topology you drawn?
No, no, I am just using my
Okay.
hands and.
Okay, fine. Yeah. Mm,
Yeah, so now we got all the information, IP address, gateway, and the DNS server. Now, if we want to ping the Google,
mm,
so first it will convert. We use the DNS,
mm,
so we need to configure the DNS. So DNS is domain name server. It will
mm,
convert the domain name into the IP address.
mm,
So now, first the client, I mean the PC will check in its local cache if
mm,
we have the IP address of Google. If the Google IP address is found, it will directly connect a TCP connection, and we will be able to access the data. If we don't have the IP address in the local cache, it will generate a recursive query to the DNS resolver. So in the DNS resolver, we will have records. Record A is used for IPv4 address, record AAAA is used for IPv6, and PTR record is used to, again, IP address will be converted back to the domain name,
yeah.
so that information it will be in the PTR. So in the in the IPv4, that is A record, it will check if we have the IP address of Google. If it is found, it will generate a
Oh,
non-recursive query, and it will
so
provide.
it means it will check your computer will check a cache. In case
Mm,
IP address is not there, that query will generate, right? Yeah.
yes,
Query will generate for whom? Whom it will generate.
it will generate a query to the DNS server.
Very good. Yeah. So the query will go to gateway. I mean DNS resolver.
Yes.
Yeah. Okay.
So now, in the DNS resolver, if there is no IP address, it will generate an iterative query. It will
Mm,
now the DNS server will generate an iterative query to the root server. Root server, it is like a master. It is the first point of contact.
yeah.
So we will have 13 different root servers. So now the DNS servers becomes the source, and the destination becomes the the root server. Before that, before we had like a source IP will be the Wi-Fi IP address, and the destination is the like the DNS server IP address.
Mm.
And it uses before the TCP, before the connection, it uses the UDP protocol,
Yeah,
and the UDP protocol source port is random, and the destination is 53.
very good.
So now it checks in its local cache, and if it is not
Yeah.
found, now it will generate an iterative query to the root server. Source becomes the DNS resolver, and the destination becomes the root server. So root server, it will tell, I don't have the IP address of the Google. I will provide you who will be having the IP address, and it will provide the IP address of the TDL.
Mm.
So TDL, now the DNS resolver will generate an iterative query to the TDL. Source become the
TLD. TLD.
TLD, sorry,
Mm.
top level domain. So now the source becomes the DNS resolver, and the destination is a top level domain.
Mm.
It will also check, and it will tell, I also don't have the IP of the Google. I know who exactly have the IP address, and it will provide the IP address of authoritative server. Now the DNS resolver will generate an iterative query to the authoritative server. Source is DNS resolver, and the destination is authoritative server. So in the authoritative server, we will be it will have the IP address, so it will provide the IP address of Google,
Mm.
and DNS resolver will immediately save the IP address, so that for the future reference.
Mm.
So now it will generate a non-recursive query, and now we got the IP address.
So
So phase
finally,
one is, yeah.
done. Yeah. So finally, you got the IP for google.com. Okay. Now, yeah, go
Now
ahead.
the phase one is completed here. In the phase two, what happens is we will use it will use the UDP protocol with the source
UDP?
will be sorry, TCP protocol, and the source will be random, and the destination will be HTTPS. It uses
Mm.
HTTPS, that is 443.
Yes.
So now in order to connect the TCP, I mean, TCP three-way handshake will happen here in
Mm.
the phase two. So for the TCP three-way handshake, we need a client and a server. So the client will send, we will have the different flags in the TCP IP
Mm.
header. So among that, we use the SYN packet, SYN flag, and the acknowledge flag here. So the client will send a SYN packet to the server stating, "Hi, I want to communicate with you." So server will also acknowledge this, and it will tell, "Hello, I also want to communicate with you," and it will send SYN plus ACK packet to the client. So now client will receive this, and it will acknowledge this packet, and that's how the client and the server session is established between. And we now the establishment is done. And now if we type the Google server, and I mean, the IP address is found and the TCP is connected, now we will be able to access the data.
Very good, ma. Fantastic. Fantastic answer. Fantastic explanation as well. Yeah. So now we are able to access the Google. I just want to check the reachability, IP reachability. Okay.
Yeah.
So if I initiate a ping, right? Okay. Now for the first time I'm initiate a ping. Okay.
Okay.
So first, before going to check the Google, I want to check my router gateway, like gateway IP. So if I initiate a ping, right? So here, let me share my screen. You understood, right? My topology, what I have given. Okay.
Yeah.
1.1 and my gateway IP, I should take same network, right? Yes or no? I have to take same network IP, right?
Yeah.
For my gateway. So here it is 100. And this is the PC gateway also. Gateway is like 192.168.1.100. Now, if I initiate a ping to 1.100 for the first time, how exactly, what is the backend process about the ping? Yeah.
Yeah, once I give the command like ping this one, ping the gateway.
Hmm.
So first it will generate an ICMP echo request, ICMP protocol. So
Okay.
ICMP protocol, it uses the protocol number one. So first ICMP echo request will be generated. In the ICMP echo request, we have different fields like source IP. Source IP is 1.1, and the source MAC is let's say we have AA as a MAC address here.
Mm.
And we have the destination IP address is the gateway IP address 1.100,
Yeah.
and the destination MAC we don't know, that will be a question mark, that is unknown for us still.
Yeah.
So this happens, and this will be buffering.
Mm.
In order to find out the MAC address for the corresponding IP address for the gateway, we use the ARP, that is address resolution protocol. Now the ARP will come into picture, and the ARP uses, I mean, the ARP is a layer 2 protocol, and it is used to find out the MAC address for the corresponding IP address. So in the ARP, we will have different fields such as the sender IP, sender MAC. So sender IP is 1.1, sender MAC is AA, and the target IP is 1.100, and the target MAC is I mean that will be broadcast.
Mm,
So now this packet will be sent to the this packet will be reaching the router.
mm,
So in the router, it will router it is a layer 3 device, so
mm,
it will check for the destination IP. The destination IP is 1.100, that is the
mm,
gateway.
mm.
So it will check the destination IP, and it will populate a routing table
No,
in the
no,
route
not route table. Yeah, you're right.
arc table.
Yeah,
Yeah,
you're right. Yeah, you're
yeah,
saying
it
that
will
only. You just confused. Yeah, that's why I won't interrupt. Yeah, it's a art table, ma.
yeah.
Yes, yes, that.
Yeah, it will populate the ARP table. In the ARP table, it will save all the information, like from which interface it came
Yeah.
and what is the IP address, and it will be storing the information in the ARP table. And now it since the proxy ARPs comes into the picture. Proxy ARP is nothing but it will generate a uh,
So
I mean,
actually,
instead of
I'm not pinging different network, right? I'm pinging same network.
okay, if it is between the same it if it you- I mean, you are saying it is in between the same network.
Same network. 1.1. My PCI pairs is 1.1. My gateway is 1.100.
Okay, got it.
Mm,
So now proxy app doesn't come into the picture. If it is network, if it is between two different networks, it is proxy app.
mm,
So now we are ping it. It reaches 1.100. Now it provide. What it will give is, let's say we have an app. It will also maintain the MAC address. So router will be also having the MAC address. So it
mm,
will, let's say we have RR1 as a MAC
mm,
address
mm,
for this one.
mm.
So it will provide the RR1. So now we got to know the destination MAC is RR1.
So
So
it will generate a replay,
yeah,
right?
echo,
Mm,
yeah, ARP replay will be given, and that replay comes to back to the switch, and now we have all the fields fulfilled. So now ICMP echo request will come into picture, and now we have RR1 as the destination MAC here.
yeah.
So again, this packet will be sent to the router, and the router will be it will,
Respond back.
yeah, it will respond back if there is, we will be able to see the gateway.
Yeah. So router will give you ICMP echo
Give the,
reply.
yeah,
Request
ICMP
reply.
echo request will be given with all the fields, and that will be
Yeah.
reaching the PC1, and we will be able to see the
Understand,
reachability.
ma. Understand. This is how we need actually. You don't need to explain all the fields. Since the beginning, I already asked, right? You need to explain all the fields. For the first time, you can start injecting the fields, and the second time, yeah, this is how you need to exact answer. Exactly, you need to answer. Very good, ma. So
Yes,
now, ARP is to find the MAC address, right? So which layer protocol is that? ARP is which layer this belongs to?
layer 2 protocol.
Okay, so it uses IP addresses, right?
No, it uses the MAC.
Yeah, in the ARP header, we have a target IP address.
Yeah, yeah, it
Uh,
uses that source IP and the target IP.
Okay, so why don't we call as a layer 3?
Because it uses we need to find out the MAC address for the corresponding IP address. So the main one is here MAC.
Mm,
That is why it is layer 2 device, layer 2 protocol.
okay, so have you seen the packet capture?
Yes,
So have you seen IP header when ARP resolution is happening? Have you seen IP header?
yes.
IP header. Are you seeing the IP header?
In which one, sir?
So when ARP request is generate, ARP request packet, if you see the packet capture, you will see layer 1, layer 2, as well as are you able to see layer 3 as well?
No, no.
Mm.
Only the layer 2 is seen.
After layer 2, what header you will see
Mm,
if you remember? So layer 2 source MAC destination MAC address is there. And after that, what you will see?
unable to recall it.
Okay, so you said ARP request, right? That ARP
Ye-
header you will see, right? ARP
Yeah,
request, if you recall
uh,
it,
yeah, yeah, correct.
the target IP, you said right already.
Yeah, yeah, target IP and the source.
Yeah, sender and target, it feels. Yeah, fair enough, ma. That's fantastic. You're very good at basics. And let's start routing part. So, what is static routing?
Yeah, static routing is, I mean, manually adding the routes in the routing table.
Okay, what is default routing?
Default routing is used whenever the destination is unknown. That time we use the default routing.
Mm,
So in the default routing, we use like we don't know the destination, and that is the syntax we use is like IP route 0
mm,
dot 0 dot 0 dot 0, and the subnet will also be 0 dot 0 dot 0 0
mm.
0 dot 0, and we use the next hop.
Very good. So can you give me one real-time example where exactly we implement this default route in which environment?
Uh, I'm in the OSPF stubby area.
That will automatically calculate. I'm asking like default routing, right? Uh, you implemented zero dot. Have you done any project or have you seen any real-time stuff where exactly we implemented default routing?
Mm,
Default routing have you configured? Have you done a
yeah.
lab? So where you have configured in which environment? Like live real-time example.
Mm. Yeah, I did the default routing, but I'm unable to recall on
Okay.
which part
Okay, I will
I
give you a
did.
clue. You did a same thing on static routes and default routes, right? The first ever project you have done.
Yeah, OS DHCP SBI real project.
Mm, that is what I'm asking the real time. Where exactly you will implement in real time? You have done the SBI real time project, right? Towards
Mhm.
so SBI router have a two ISPs.
Yeah.
So what you configured on SBI router? What routing you have
Mm.
configured?
Yeah, when the first the ISP fails, we have
Mm,
to use the backup router. That time we have
yeah.
used this default routing.
So I'm sitting in an enterprise network. Suppose like in any bank, okay, a bank router. I have two
Yeah.
ISPs. So if how can I suppose Airtel it is
Mm.
connected to Airtel, it is
Got
connected to Tata. So if I prefer Airtel, how can I configure the default route? If I want to prefer
So,
Airtel, yeah,
okay, if I want to prefer the Airtel means for the default routing you're asking,
yeah,
sir?
for the default route, I'm asking. So I have Tata
Okay.
and Airtel. I want to prefer Airtel first, then after Tata. I have two circuits. One is Airtel, another one is Tata. But my primary path is Airtel, and I can choose secondary path as Tata. So how you configure default route here? Have you configured?
Yeah, I configured, but I'm unable to recall it.
Okay. So what is okay? I will give you a clue. What is administrative distance in routing?
It is the trustworthiness of the route.
Now are you able to recall?
AD value.
So okay, what is the syntax of default route?
Yeah, it is IP route
Hmm.
0 dot destination and the subnet mask and the next hop address.
Okay. After next stop, have you given anything to prefer?
Exit. Yeah, exit interface.
Yeah, exit interface. You can give an next stop or as the exit interface.
Yeah, AD value.
Yes. So if you want to prefer
Okay.
Airtel, you will give a lesser AD value, right?
Yeah, yeah,
Yeah. So yeah,
got it.
that is it. You're
Correct.
able to recall
Yeah.
now?
Yes, yes.
Yeah, fair enough. Okay. What is OSPF?
Yeah, OSPF, it is one of the dynamic routing protocol. It
Mm,
will automatically add the routes in the routing table,
mm,
and it is one of the link state routing protocol, and it
mm,
uses the Disgustra algorithm, and it will calculate the best path, and it will be added in the routing table,
mm,
and it uses multicast address 224.0.0.5 to
mm,
discover the neighbors,
mm,
and it there is no restriction on the OSPF routers. It can be configured on unlimited hops,
mm.
uh, and then it
Yeah,
uses the yeah,
yeah, I
hello
understood.
timer of 10
Yeah,
seconds
yeah. So you said right, it will use hello packets to discover the neighbors. In which state the neighbors are discovered?
in the two-way state.
Which state? Very good. So how many states we have total?
We have 7 states in total. One is down state, init state, two-way state, exchange state, start state, exchange state, loading state, and full state.
Okay, what will happen in X start state?
In the start state, the data synchronization will start here. From
Mm,
here, it will be unicast. It will be
mm,
unicast,
mm,
and here the master and slave will be elected based on the router ID. Whichever
mm,
is having the highest router ID becomes the master.
mm.
Whichever having the lowest router ID becomes the slave.
Okay, so very good, ma. So now uh, we have LSAs, right? So
Yes,
which carries the routing information.
route. Yeah,
Yeah. So how many types of LSAs we have?
we have 11 types of LSS.
So very good. So whatever the known LSAs, like who will generate, what is type 1, type 2 LSA?
Yeah, type 1 LSA, it is the router LSA. It is
Mm,
generated by all the routes in the OSPF domain.
mm,
And the type 2 LSA, it is network LSA. It is generated by DR.
very good.
And type 3 LSA, it is combining type 1 and type 2 and becoming the network summary LSA.
Mm,
And this is generated by ABR, that is
mm,
area border router.
mm,
It is the router which will share the two areas in the same
mm,
area with the same area. Two
mm,
areas are connected to the same area.
mm,
And we have the type 5 LSS, that is external LSS, that are generated by autonomous, no, sorry, ASBR. That
okay.
is when we have ASBR, it is the route, it is the one which connects the OSPF domain to other
Mm,
routing protocols, and it will generate the type 5 LSS, so that the external routes can be advertised in the OSPF domain.
mm,
And then we have type 4 LSS. Type 4 LSS are generated by again ABR,
mm,
so that the other areas can reach the external routes.
mm,
And we have type 7 LSS. Type 7 LSS is also called as NSSA summary LSA.
mm,
So whenever we configure the NSSA as area,
mm.
that time type 5 is will be generated, and later ABR converts the type 5 into type 7 into type 5, so it will be advertised to the other areas.
Super, ma. I just asked one thing, but you explain everything. Fantastic. What is stubby area?
Stubby area, it is like one of the feature which is used to reduce the routing table. We
Mm,
have it will reduce the size of the routing table.
mm,
Once we configure the stubby area, particular area as a stubby,
mm,
it will initially stop the type 5 LSS, external LSS. It will be stopped, and ABR will generate a default route,
mm.
and through which we will be able to reach the external.
Yeah, fair enough. Okay. So now, what is BGP routing protocol?
Yeah, BGP, it is one of the external EGP, exterior
Mm,
routing protocol. It
mm.
is used to exchange the routing information between the two different autonomous now system.
What is autonomous system number?
System number, it is one of the number given to the router, so that we will get to know which router belongs to which company.
Mm, okay. It represents the administration, like it comes on all
Yeah.
the routers comes on the same administration. Okay, fair enough. So, do you remember the range of autonomous system numbers?
Mm, yeah, 0 to 65535.
Very good. So, do we have private and public AS numbers right here? Do you know that what is the private AS numbers, private or public?
Yeah. Mm,
Do you know, right?
uh,
It has unable to recall.
eh, yeah, I'm unable to recall it.
Okay, ma, no problem. So, how many BGP messages we have?
We have four BGP messages. One is open.
Mm,
Open, it is used to initialize the BGP session.
mm,
And we have the keep alive message. Keep alive message, it is maintaining the session, and it will tell I am still alive.
mm.
And then we have update message. It will exchange the routes. I mean, it will advertise the routes. And we have the notification. Whenever there is an error, it will be terminating that particular session.
Yeah, neighbor. Yeah, in case whole time expire or something. Very good. Yeah. So, how many states we have in BGP?
We have six different states. One is ideal state, connect state, active state, open confirm state, open send state, open confirm state, and established state.
Very good. And if my BGP neighbor stuck in connect state, what kind of troubleshooting you will do?
Okay, if BGP is stuck in the connect state, the SYN plus ACK packet should be received. If it is not received, it will wait for 180 seconds, that is
Mm,
3 minutes.
mm,
Even after waiting for 3 minutes, if it doesn't receive the SYN plus ACK packet,
mm,
then it will reset it. It will
mm,
reset to zero, and it will send it to the active state.
mm,
In the active state, again a new BGP IBGP session should be established,
mm.
and until the three-way handshake process is completed, it will be jumping between the connect state and the active state. Once the TCP three-way handshake is completed, it will be moved to the next state.
So you mean my neighbor stuck in connect state? Three-way is not happening, right? So what could be the
Yeah.
reason? Any reason? Yeah. How you will troubleshoot?
Okay. Um,
So
if it is struck,
yeah, go ahead. Yeah,
yeah, if it is stuck in the connect state, means there will be issue in the three-way handshake process.
yeah.
So we need to establish again a client and the server session
So
will be established again.
yeah, what kind of troubleshooting check? Like you got to know it's stuck in connect state. Synac is not coming. So if you want to initiate a TCP session, first what exactly it will check? Check with the destination, right? What is the first step? It will check. So you said
Uh,
right DNS part. So once it learns, after learning the IP, so how TCP established? If I want to establish a connection, what is the first step for establishing a connection?
I mean, you are asking regarding the ports.
Whatever it is, I'm just asking if I want to initiate a connection, okay, to some destination, like what is so TCP suppose BGP neighbor here 1.1, 1.2 neighbor IP 1.2 here source IP 1.2. So source IP is 1.1, destination port is 1.2, and source IP random destination port will be 179, right? BGP.
Yeah,
Yeah, correct.
179. It
So that
uses
packet will
170.
go to other router. So now you tell me, it is not sending SYNAC.
So once it reaches the R2 receives the destination port as 179, it will recognize as its own, and it will see all the other fields,
Mm.
like what is the source. Source is like 1.1, so it will be expecting a SYNAC packet from the R1. So if
SYNAC
the
from
SYN
R1 or see this is
is
R1.
R1 is expecting a SYNAC from R2, sir.
So it means R2 is not sending. If R2 is not sending, R2 not receive the packet, right?
Yeah,
So
first R1 should send the SYN packet to the R2, and
yeah,
then it will.
R1 is sending SYN packet to R2. So R2 is not responding means what could be the issue?
It is not acknowledging it.
Yeah, R2 is not responding. What could be the issue? So suppose if I'm calling Rashmi is
Yeah,
not
if
responding.
the TCP port is blocked, might
Mm,
be the reason. It might be
okay,
not sending.
fine. DCP port is not blocked. Okay.
Okay.
And then TCP port is not nothing is blocked. So first you have reachability, right?
Yeah, yeah. We need to check the reachability if
Mm,
there is a reachability between R1 and R2.
yeah, reachability is there. Port is not blocked. Still anything else? Why still it is not sending SYNAC?
Mm, mm, that's it, sir. I'm
Okay,
unable
no
to.
problem. So yeah, those are the very important thing, whether port is blocked or not, and other thing is
And
reach. First thing is reachability.
three-way handshake. Yeah.
Yeah, in case if you have reachability, then only you will initiate TCP
Yes. Correct.
sync segment, right? Yeah. Now, now, what is the BGP path selection process?
Yeah, we have like path selection process. First, we will check next hop reachability,
Mm,
and next we will see whichever is having the highest local preference, and we will see whichever is having smallest AS path
mm,
and smallest origin, and then we will see the smallest med value,
mm.
and eBGP is preferred over IBGP,
Mm.
and the smallest value, IGP metric to reach the next
Yeah,
hop.
fair enough. Now, um, you said these all are attributes, right? So how many attributes you have? What are the well-known attributes here?
Yes, we have like well-known mandatory attributes, well-known discretionary attributes, and the optional attributes. In the well-known mandatory attributes, we have three: AS path, origin, and next hop.
Okay.
And in the well-known
Yeah, continue.
discretionary yeah, in the well-known discretionary, it should understand the attribute, and it may or may not
Yeah.
carry the attributes. In that, we have two types: one is the local preference and the automatic aggregator.
Yeah.
In the third one, optional attributes, it may understand or it may not understand, it may carry or it may not carry the attributes. In that, we have optional transitive, which will carry the attributes, and non-transitive, which will not carry the attributes.
Mm,
Under the optional transitive, we have like two: one is aggregator and the another one is communities.
mm,
In the communities, we have four different types: no export, no
mm,
advertise, internet, and local AS.
mm.
And in the optional non-transitive, we have med, cluster ID, and the originator.
Okay, fair enough. So yeah. So you said community, right? If I use no advertise on the BGP peer, what it will do?
It will not advertise to the another AS.
Very good. Yeah, fair enough. So you know these attributes, right? And you know the path selection process. So now my company have two routers, R1 or R2. I have two exits to reach destination. So I want to influence outbound traffic and inbound traffic. What you will do?
Okay, to influence the inbound traffic, we use the attribute that is AS path prepend.
Hmm.
When we use the AS path prepend, whenever it sees the same AS value, if it is seeing the its own AS, router is seeing its own AS value, it will remove that one. It will remove that one. It will not accept. It will reject. That's how we will.
That
It
is
is
called
this.
loop avoidance, right?
Yeah, that is the loop avoidance.
Mm,
And if we want to influence the outbound traffic, we use AS path prepend.
mm.
In order to influence the inbound, I mean outbound traffic, we use the local preference,
So you
and
said outbound traffic two times. First of all, let's stop it. Let's understand outbound traffic. It means from your device to your
it is exiting.
exit
Yeah,
means which attribute you will use?
uh, I use local preference.
Very good. So now local preference, how you will apply this, how you configured it. Just
Yeah,
basics.
I will increase the local preference. The
Mm,
owns route, my own routers a local preference.
mm.
If it is 100, I will give it as 300,
How you will increase? What is the process to increase the local preference?
I use the path manipulation, and I mean route map. I use the route maps,
Mm,
and in the route maps, I will give the permit one, permit 10, and then I will set the local preference
mm.
as 100, and then I another
That's
route
100,
map.
100 is yes path. You are preparing your own yes. Whatever you're saying is correct only. You're talking about local preference, right?
Sorry. Yeah,
Yeah,
sorry. I'm confusing between the
yeah. Take a
inbound and
breath. You're
outbound.
saying correct only.
Yeah.
Yeah, just take a breath. Yeah, yeah.
Yeah, sorry. For the local preference, I will increase. I mean, I will we can either increase or decrease.
Mm,
So let's say we have the local preference as 100 now.
mm.
I can either increase it above 100, or I can decrease it below
Below
100.
100. Yeah,
And that's how I can do the path manipulation by setting the local preference to, let's say we will set it to 200,
mm,
and that's how it will choose the highest path. It will
yeah.
be choosing the local preference. That's
So
how we
now you
can
will create a route map. You will apply in import direction or export, like in or out direction. Which direction you will apply?
in the out direction I'll apply it.
Yeah, from your border router to your
Yeah.
internal. Yeah, fair enough, ma. Very good. So what is split origin rule?
Split origin rule, it is nothing but we should not advertise the routes from one IBGP peer to the another IBGP peer,
Mm,
because if it one IBGP peer receives the same routes in of the I mean same IBGP peers,
mm,
that will create the loops. So
mm.
in order to avoid those loops, it should not receive the same IGP peer routes. So
IBGP.
that's
Yeah.
how we will
Okay.
avoid the loops.
Okay. So now single straight questions and answers. Okay. I will ask straight questions. You can answer it. What is the SSH port number? TCP port number.
The SSH port number is 22,
Telnet.
23,
HTTP.
80,
HTTPS.
443,
Okay. DNS.
53.
Okay. DSCP.
67 and 68.
What is 67? What is 68?
67 is source, 68 is source, 67 is destination port.
Very good. And what is the protocol number of ICMP?
1.
What is the protocol number of OSPF?
Protocol number of OSPF.
You're almost
OSPF
there. Yeah.
89.
Okay. What is the protocol number of EIGRP?
I'm
That's
able to recall the
that's
AD
correct.
values, but
Yeah, that's why you may confuse. So 89 is the correct answer. Yeah. What is the protocol
yeah,
number of EIGRP?
EHRP 79.
Ma, 79 protocol number.
89. 1 second. EIGRP
It is just
6.
88 only. It is, 89, 88 is the EIGRP and OSPF.
Okay.
What is the protocol number?
80,
Yeah,
88.
it's okay. It's okay. What is the protocol number of TCP?
TCP 6.
UDP,
17.
VRRP? No,
No.
VRRP. Okay, fair enough. So now, what is the difference between protocol number and administrative distance?
Uh, Protocol number, it is the number given to the
Mm.
mm, I mean,
Yeah, you're
it
right.
is number given to the protocol, whereas the AD value, it is the trustworthiness of the route.
Okay, so in my routing table, I have OSPF route, static route. What is the OSPF AD value?
OSPF AD
AD
value is
value
110. 110.
110. What is the static route AD value?
1.
1. So now 10.10.10, 8.8.8 is my Google. Slash 32. It is learning via OSPF. 8.8.8 slash 24, it is learning via static. Which one it will choose?
32.
Okay, you mean static?
Yes, first one.
Why
8.8.8./32.
why not it is choosing static?
So the order,
Mm,
the selection is like, first the longest prefix will be preferred.
mm,
Next will be the shortest. If the prefix matches, then it will check the shortest AD value, and
perfect.
then the cost metric.
Very good, ma. Such a wonderful interview. Really, so proud of you. I have seen, you did a fantastic labs. Now your labs, your hard work speaks a lot now. So the advantage, the good, I want to give a feedback. The main thing is whatever I'm asking, you're only answering that. You're not answering extra. Initially you are giving packet level for 2 packets, then for other packets you're just explaining normally. That is how you need to answer it. Okay, and whatever I'm asking, you're clearly answering it. And if you're not able to answer it, you're not able to recall it. Yeah, this is how it is. I don't have anything to say, improvement and all. Fair enough, it's very good. And I'm very curious, since you have 5 years of experience, what motivates you to enter into this networking journey?
Uh, Initially, when during my engineering days, I not used to like this subject at all.
Oh.
After I passed out, first I thought my interest is towards the VLSI,
Mm.
so I tried in the VLSI domain.
So you
Uh,
you are a easy student?
yes, I'm EC student.
Okay, okay.
Yeah, initially I had I was interested in VLSI. Then later, I started giving interviews and I got selected for one of the this is the Verizon networking
Mm,
project.
mm,
So I was like, okay, now I need to learn the networking, because initially I was not interested.
mm,
But I thought, okay, if I'm getting this challenge, let me take this challenge and let me learn this, which I don't like. I have to exceed in that particular network only. So let me accept this challenge, and I started my networking journey.
mm,
I learned everything step by step. I have learned everything, and after learning it, I enjoyed it. Like, I started enjoying it. Like,
mm,
whenever I resolve one issue, I used
mm,
to feel so much happy.
mm,
It used to give me so much happiness.
mm,
And whenever the customers used to tell us, so
mm,
I'm really happy with the service you have given, like
mm,
whatever troubleshooting you have did,
mm,
you just quickly gave us the resolution, which will take like 1 to 2 days. You resolve just in like on the call only you have
Yeah.
resolved.
Mm.
That feedback used to motivate me more, like,
Okay.
okay, okay, this is my field, I have to exceed in this field only. So
Very
that's
good.
why many people told me to change the field. I mean,
Mm.
you can jump to the other field and you will get good packages. But I said no,
Mm.
I don't want to change my domain. I
Mm.
want to stick in the networking field only.
Mm.
I want to do some certifications. I
Mm.
had this plan initially, from 2 years back. I had this thought in my mind, but finally, I was unable to do the certifications. But finally, when I joined the Tungabhadra Networks,
Mm.
under your guidance, I learned so much. I gained so much knowledge, and I even cracked the. I mean, I got my first certification, that is
Yeah.
from Juniper. I
Yeah.
cleared it, and I'm so happy, and I'm very
Yeah. I saw
thankful
it.
for you.
Yeah, I saw it, Ma. This the passion you have is like extremely. You know, you are one of my best student. Yeah, and I really appreciate you. So do not lose your passion towards this
No, sir.
networking. Now you know what is networking importance and all. So definitely, if someone watched this, uh, our interview, this interview went very well. Do you have any questions, Ma?
No, sir. I'm just grateful and thank you for sharing the knowledge, whatever you have. The way you teaching, even from the packet level. Even I had an experience of 5 years. Sometimes I used to lack. I mean, I didn't know what is the exact process, what is the step by step packet level. When once I joined here, I got each and I used to daily do the ping process, everything. I used to
Mm.
ping the device
Yeah,
every day,
daily.
each and every day, like almost like 50 times, 100 times I used to ping. But I didn't know the packet level. Once I got to know about the packet level, I'm now enjoying that process.
Yeah.
Okay, this many times I used to ping, and now I got to know what is the packet level, and that's really
Very
helped me a lot after joining here. Your knowledge is like a big ocean.
good.
From that, I at least got to know a few things. That is, I'm very glad about it, sir.
Yeah, ma, really, really appreciate your words. And yeah, this learning is continuously going on. You know, right? How we learn. And the
Ye-
next, you already learning CCNP. I would like
yes,
to ask MPLS questions, but not this already extended to 1 hour. So we can take part two. So is it okay to
sure.
upload this in YouTube?
Yes, sir.
Yeah, very good, ma. So I hope if anyone watch this, right, definitely if they have any openings, definitely they should call you. Are you looking for job change, right?
Yes, sir. I'm currently looking into the product-based companies.
Very good, Ma. Let's do this and all the very best. And
Thank you, sir.
I will also refer you. And yeah, and I'm so happy because people are having packet level knowledge and showing skills and a right platform is very important. Companies are looking for a candidates like you, whoever knows the packet level, because we have to take a packet capture, analyze the things, and need to identify the complex issues. Yeah, great,
Yes.
Ma, and all the very best. See you soon with
Thank you,
part
sir.
two. Meanwhile,
Yes,
let's
sir.
see.
Sure, sir.
Yeah, let's see. Meanwhile, if you see any good news, okay, regarding product
Sure.
based company. Yeah. Thank you
Yes, sir.
so much, and thank you so much your time as well. I will share this in YouTube, and yeah, let's see. Okay, now. Thank you,
Yes,
ma.
sir. Thank you,
Have a
sir.
nice day.
Thank
Yeah.
you. Yes, sir. Thank you. Have a good day.
Thank you, ma. Bye.